Hi, everybody. Hayes' World of Math. Welcome back. I'm Mr. Hayes, and I need a haircut. But we're going to put that to the side because we have to get you ready for the AP. All the notes that I'm doing are located down below in the link. Feel free to grab those, use whatever you want. Go ahead and hit subscribe and the like button and all that other good stuff that YouTube viewers should do. Let's get going. So the first question that we're going to look at is out of 2018. And there was this environmental science teacher at a high school, large population of students. They wanted to estimate the proportion of students at the school who regularly recycle plastic bottles. Teacher selects a random sample of students to survey at the school. Each student goes into the teacher's office one at a time and answers the question, do you regularly recycle plastic bottles? Based on the responses, a 95% confidence interval was built, and it was calculated who said yes, and it was calculated between 0.584 and 0.816. Hopefully some things are already going through your head in terms of how things were built and how things were done. We're going to get to all of that as we go. But again, remember, as with my theme, answer the question that's being asked. So in this case here, the first question is how many students were in the sample selected by the environmental science teacher? Now, this right here can often throw people just because there's a fair amount of algebra in it. Just don't panic and you'll be fine. So remember, confidence intervals is our mean plus or minus our margin of error. So in this case here, our margin of error is going to be z times the square root of p times 1 minus p all over n. So we need to find a few things first because what we want to get is n. So that means we need to figure out the z, the x bar, and the p. So we can plug those parts in and solve for the missing part. Now for x bar, it is, you just take you average the ends of your confidence interval. So I take 5.84 or 0.584 and 0.816, add them together, divide by 2, and I get an average of 70 right over here. So that is going to be my x bar. To find your margin of error, I probably should have labeled this, my apologies. So you just need to find the distance of the end of the confidence interval. Apparently my writing is awful. Between one of the ends and the margin. Or what you could also do is do the same thing as what we did up here, but subtract it and go from there. Either way, your margin of error is 0.116. So we know that this is going to equal 0.116. And so we don't care about the 0.7 for right now. We do because we're going to have to use it on the inside. But what we're going to end up doing here then is we're going to say, okay, this 0.116, the margin of error, is equal to my z-score. Since it's 95%, we're going to use 1.96. And then since this is my p-value, actually I shouldn't have used x-bar, I should have used p, my apologies, or p-hat. So right up here, we've got 7 times 0.3 all over n. Okay, there, now I feel better. So we go through this. So p-hat's 1.16, or we're going to plug this in. So margin of error is 0.116. Z-score of 1.96. My p-value is 7. 1 minus 0.7 is going to be 0.3. And n is the part that I'm looking for. So to do that then, what we're going to need to do is obviously solve for n. A couple of things. Again, you probably want to isolate the root first. So if you isolate the root, I went through and I divided by 1.96. And I'm squaring both sides. And when I do that, and apparently, obviously, I ran out of room. So then I get 0.21 over n equals this squared, multiply both sides through by n, divide by this, and I get this mess right here. I'm not plugging anything in until the very, very end. When I type all of that stuff out, I get n is equal to 59.95. Now remember, that is always the smallest value that we can have, so we need to go a little bit more conservative, so we're going to push it out to 60, because if we said 59, it wouldn't work. So that means that means this teacher had 60 students in terms of what was going on, right? So 60 students came and answered this question for this confidence interval. Now, given the method used by the science teacher to collect the responses, explain how bias might have been introduced and described how the bias might affect the point estimate of the proportion of all students who responded yes to the question. So then for this one here, what's going to end up happening is this. Now, a couple of things. Think about what happened. It was a random sample, but how did they answer the question? And so they went in and they talked to the environmental science teacher. And so bias may have been introduced due to the teacher asking the students the survey question directly. Students may answer they recycle, either due to thinking that the environmental teacher would prefer that or not wanting to admit that they don't recycle. And so because of that, what ends up happening is that your p-hat value is going to be much higher, or your p-hat estimate for the population is going to be, for the proportion is going to be higher than what you want. Notice here I didn't necessarily specifically say what type of bias we're talking about. One of the reasons for that is because if you're wrong with that, then it's my understanding, and readers, please feel free to correct me down in the comments, that if you say something wrong like that, they have to take some points off. But if you don't necessarily say what type of bias it is, but again, because what's the question asked, it's saying explain how bias might have been introduced and describe how the bias might affect stuff. It didn't say what type of bias, it just said explain what bias or how bias would affect things. Then they can give you full credit for that. All right. So then for the next part, they ask you, okay, now what happens if the statistics teacher, because we're pesky like this, was concerned about the potential bias. So to obtain a less biased survey, they did the following. They took a random sample of 300 students. Each student was given the instructions on how to respond. In private, they flip a coin. And if heads, you must respond no, regardless of whether or not you recycle regularly. And if there's tails, you're going to truthfully respond yes or no. Because the expected number of students, what is the expected number of students who would be required to respond no to the coin flip? Well, okay, the expected number of that would just be half of the 300, right? So you would have 150 students that you would expect to have to say, nope, I don't recycle. So then from there, what must the results showed a sample of 213 out of the 300 students responded no. Based on the results of the sample, give a point estimate for the proportion. And again, I've circled that we're saying a point estimate and a proportion just to make sure that we're answering what we're supposed to of all students based that must respond, or that would respond yes. So out of the must answers, we have 150 who have to answer no. Okay? And we're just assuming it's 150, might be more, might be less, but the expected value is close enough. So we're going to take out of those 213, we're going to take away 150 of those no's. So that means we have approximately 63 real no's out of the 150. Then from there, we have 87 students who answered yes, right? Because that's the difference between the 213 and 300. So that gives us 150 students total who were not told to answer no. So then from there, we have 87 out of 150. That gives us a 58% value of students who would say, so the approximate participation who say yes, they recycle is now 0.58. All right. That's it.